I have a little dance to the subject of bunker vessel design. So I'm going to quickly go through the history and development of LNG shipping, just to give a bit of history and show some pictures of nice boats with camber and parabolic shear. Then quickly look at the LNG supply chain and utilization chain for floating assets. Very quick look at that. Then turn on to what is a fairly new use of LNG, which is a bunker fuel instead of MDO or MGO or heavy distillate fuels, and some current and future development trends in LNG bunkering. Then on to what really is the crux of what I want to try to discuss, and that's the scoping, development, design, and before the design, the operation. So it's design for operation of LNG bunker vessels. As I'll come to the quite new and quite novel, and then try to draw a few conclusions, and then hopefully at the end you might want to ask me a few questions, and if they're not too difficult, I may be able to answer them. So I hope you do enjoy this. I hope I don't keep you from your tea too long, and well, sit back, enjoy, and try to stay awake. Okay, I'm going the wrong way. So the LNG, its history. The first utilization of LNG was after the Second World War. It was started to be developed in the mid 1950s, but finally came to fruition in the late 1950s through the conversion of an old Liberty ship. Well, not so old; she was only about 10 years old. The Marlene Hitch, which was built in 1945. And she was converted for use as an LNG carrier. There's a picture of a bit of a grainy picture of her. I'm sorry about the quality. She had a number of conch type tanks put in the cargo holds, and you can see the slightly raised deck that came to store those tanks under the deck. So she was a standard sort of Liberty ship of about 5,000 tons, and she ran from Lake Charles in Louisiana in the States to Canvey Island. I think she did about 18 or 19, maybe a few more voyages over a number of years. But the first one, she left the 27th of January 1959 and arrived in Canvey Island in the UK in the Thames Estuary 27 days later. That was the first of LNG, and the amount of LNG that was sent on that occasion was about 5,000 cubic meters. So if you just hold that figure in your head, 5,000 cubic meters in 1959. As it says there, the tanks were aluminium, sort of freestanding vertical type tanks. Moving on now to what the LNG and LPG fleet looks like today. Well, it's come on a little bit from a small little Liberty ship to something approaching a couple of thousand vessels. Now, I'm talking here about cryogenic vessels in total, not just LNG carriers. So you can see these LPG carriers, there'll be LEG carriers, ethylene as well. LPGs nominally about 48 degrees below zero. Ethylene's probably about below 100, and LNG's minus 163. And you can see there that there's a lot of ships and a lot of big ships. Probably now, just to give you a feeling, a standard LNG carrier that gets ordered now is in the region of 170 to 180,000 cubic meters capacity. The one on the bottom right-hand corner there is a prismatic type B, sorry, not prismatic, a cylindrical type B, Moss type containment system, 4 balls, and that's probably in the region of about 140,000 cubic meters. So you can see now, as of today, and these figures are as of this month, there are 564 LNG carriers in operation. But the interesting figure behind this isn't the increase from what it was in 2019, and where it's grew by, nearly 30 vessels. and that's quite a lot to be constructed. Bear in mind these vessels are very expensive. Probably a price tag, say nominally $250 million, something like that. There are 132 currently on order and under construction. So that's 20% of the existing fleet is actually under construction now. So the fleet is growing at quite a substantial rate. And if you look across to the yellow box on the top, the growth of the market, you can see there was 58 delivered in 2018, 14 in 2019, and there should be another 32 this year. So 32 have entered service this year, and another 13 before the turn into 2021. So there's about, let's say, 500, 5,500 LNG carriers. In comparison, LPG carriers, there are 1,500. Now, these can be of all different sizes. Most of the LNG carrier fleet is probably the older tonnage is about 125,000 up to about 180,000, apart a couple of ship types, which I'll come to in the next slide. The LPG carriers are a lot smaller. They tend to use a different containment system, which is prismatic type B tanks. But of those ones, and you can go from, the typical would probably be about 30,000 cubic meters. But the VLGCs, which is a very large gas carrier, LPG, are probably about 80,000 cubes. And you can see there 300. So there's still a significant amount of the fleet is of the large type, and there's a 12% of that fleet is new construction, and that's grown from last year, which you can see the figures in square brackets to the right of the bold figures. That's grown from 15 on order in 2019 to 45 this year. So example of a VLGC, very large gas carrier, and that's LPG, liquid petroleum gas, is the red vessel on the right hand side with a flush deck. LNG carriers are usually either have trunk decks, which I'll show you a slide, which have the next slide, which have use membrane type tanks, which are insulated membranes attached to the hull itself, the steel of the hull, or freestanding cylindrical type B tanks, the Moss type tanks, looking like golf balls. There's less of them being built now than membrane ships. And there are a couple, just two SPB ships of about 75,000 cubes of LNG carriers. You can see there that over 75% of the ships in existence now have been the Far East built, Japan and South Korea. It's been a number of years now since a vessel was built in Europe, and it's probably, I think, probably the 80s since a vessel was built in the US. But now China's coming along. Hudong has started to kick out a lot of vessels and has done for the last decade or so. Okay, so I said to you the standard conventional, if we call it a conventional LNG carrier, is about 180,000 cubes. These are the largest ones. So these are all run by Nakilat out of Qatar, and these, the ones that's shown there, are what are called Q-Max, so Qatar Max ships. There's 14 of them built. They were built about a decade ago, and they actually have a storage capacity of 266,000 cubic meters, approximately, depending on the type of containment system, whether it's a Mark III or an NO96. I'm not going to go into the different membrane systems in this lecture, but you can see they are very large boats, nearly 350 meters long, 55 meters wide, but they're drawn 12 meters, which is the classic dimension to fit into the berths and get into harbors. And normal conventional carriers will usually be somewhere between 11 and 12 meters, and these vessels are now draft limited. To a certain degree, LNG carriers are also length limited for the berths, and that's usually 300 meters. As you can see from the next class, which is the Flex, of which there was 31 built in the same series with the Q Maxes, and you can see they are slightly smaller, 210,000 cubic meters compared to 266, but are still larger than the typical ones of that age, which was probably about 140 to 150,000 cubic meters. Saying the typical now is 180 to 170 to 180, and you can see they are now, the beams come down, the lengths come down, but the draft's still about 12 meters, the max out at 12, and very large ships. So NACLAT built these. One thing to mention about these ships, there weren't steam queens. There were slow speed diesel, twin shaft slow speed diesel ships, and they actually ran on liquid fuel. They didn't. They don't burn the boil off gas, which is inherent with an LNG carrier. There will be some warming of the cargo, and some of it will boil off. They actually have full reliquefaction on board. The reason why a lot of the carriers, until let's say just under 10 years ago, were all steam, because they burnt the boil off gas, and there wasn't a way in internal combustion engines. These big diesel engines weren't available. They then got vessels of the conventional type, from 135 to, let's say, about 170 cubes, which have medium speed electric drives, and even the big ones that are now built for Arctic service, the ARC7 ships, they still keep diesel electric, but most ships have now gone to big cathedral engines, back to slow speed diesels, but either those by WinGD or MAN, which burn gas, so they burn the boil off gas. But earlier this year, or late last year, no, it was earlier this year, no, late last year, NACLAT announced that it was going to do another tranche of building, possibly up to another 100 ships, with an investment of approximately $10 billion. I'm not sure if any have been placed yet. I don't think they have. Obviously, there's a good chance that the previous yards that built them, the big three in Korea, that's DSME, Hyundai Heavy, and Samsung Heavy Industries, will be in the running. Probably also Chinese builders will go for those as well, and I guess the negotiations are ongoing. Obviously, COVID might have affected the progress of those negotiations, but this is one of the largest fleet expansions to date, as you can see. Even 100 ships, even given that a lot are being built now, there's about 100 on the stocks. It's still a massive investment, and it's an increase of 10%, over 10% in the fleet, and that's there to support Qatar's expansion from the current output of Qatar of 77 million tons per annum of LNG up to 110 MTP. Sorry. Okay. So back down to industry. The first serious trade took place in 1994 from Algeria, which was one of the first exporting country really of LNG in any significant amounts. And two ships were purpose built for this. The first two purpose built LNG carriers, the Methane Princess and the Methane Progress. They use conch type tanks, and these two vessels were 27,000 cubic meters, so that's a big increase over the 5, but nowhere near the common that was settled to probably in the late 1970s of about 125 to 130,000 cubic meters. And these were real firsts, steam ships, first, but the last one's built in the UK. Then all building happened in Norway and Northern Europe and France, Spain, places like that. The production of worldwide production and trading of LNG is 430 MTPA, of which over 80% is exported, and that's all exported by ship. And that's an increase you can see on the previous year, 2018, for which I have figures of about 7 to 8%. As I mentioned, we're talking about the Q-Max and Q-Flex ships. They are to support the export of LNG from Qatar. Qatar became the biggest exporter way back in 2006. And as of last year, Qatar produced nearly a quarter of the world's LNG with 77.8 MTPA. However, it was rumoured, and it nearly happened, that Australia would overtake them, and they nearly did. They exported 75.4 MTPA. And the third and fourth runners are USA and Russia, respectively, who are significantly less at 34 and about 30 MTPA. Because of the cost of the carriers, and the carriers are probably one of the most expensive, or not the most expensive cargo vessel, non-passenger carrying cargo vessel in the world. Originally, the LNG Trade was a liner service for the liquefaction plants, and also the reception plants and gasification plants on shore, of which you can see examples on the second and bottom slide on the right-hand side, is very significant. However, in the last decade or so, a spot market has emerged. There's a lot of ships out there, and day rates are fairly healthy at about, let's say, in a nominal $150,000 a day. And this is a fact that is only going to go up due to the desire to try to have a cleaner energy source. Is 25% of the world energy market is natural gas at the moment, and 11% of that is actually LNG. So it's a significant source of energy. And as I said, this is all driven by the need for clean fuel, substitution of old fuels, for not just vessel running we're talking about now, but obviously heating, electricity, things like that. Okay, so let's look at the overall production, the history and distribution of that. In 1970, long after the exportation began from North Africa, it got up to 3 MTPA. As I said, last year, it was 316 MTPA, and that's increased this year to an estimated 355 MTPA. And as I touched on, as I mentioned before, the growth is about 7% year on year on year, with a predicted growth in 2019 of about 13%. And there's no reason why this won't continue. And some of it, as I'll come to later, will be from floating facilities, but there's been a little bit of a hiatus in that at the moment. At the beginning of last year, the world liquefaction actual capacity was at 393 MTPA, increasing this year to 430, and by the end of this year, online it should have increased to 455 million tons per annum of LNG. As that says, the additional capacity on board was 30 MTPA at Q1 2019, and 37 MTPA at Q1 2020, and there's another 71 has gone through FID, and a figure of 907 MTPA is at pre-feed of whatever stage of pre-FID. Obviously, a lot of those might not materialize, but it's a significant increase in the production capability. And just to give you an outlook, these are quite small figures, I apologize. The circle, the little pie chart in the sort of center of the screen is the exporting. The one between 12 o'clock and about 3 o'clock, about a quarter, that's Qatar. Then you've got Australia, then you've got the States and Russia. The important countries are the pie chart to the right, and the biggest one, the one at about 22%, is Japan, and then you've got South Korea at the bottom there, and in between them is China at again nearly 20%. So you could see all the production is centered away from where the content's required because of the lack of resources in the Far East. And just to give you a feeling, 100 MTPA production needs about 60 standard LNG carriers to transport it around the world, which is why you're seeing, because of this increase in production capacity, therefore you need the increase in transportation capacity. Obviously, you then also need the increase in reception and gasification capacity on shore as well. And just to show that the US figures for shale gas, they've increased tenfold in just 6 years. So it's a very healthy market. Okay, so let's go into the supply and utilization chain. So as I've alluded to before, there's obviously a number of links in this chain, and I'm going to look at them in our case just because I guess we're all people that either design, sail on, or operate ships to talk about floating facilities. As I say, traditionally, most of it was always land-based. So the first one is the liquefaction processing of the gas. Do that at a liquefaction plant, and we now have those at sea floating. So this one's a 3D image of Shell's Prelude off northwest Australia, which I was lucky enough to work on up until FEED, and worked on concepts probably for about 10 years, from about 2000. There were other ones for off Southeast Asia, off Africa. There are heavy investments. There's a little bit of a hiatus at the moment, but it's a technology that has its place in the whole energy system. There's a slight adaptation of that, in that you could have what's called just a pure liquefaction system. So all the processing of the hydrocarbons is all been done before. So you just have a process plant. So this one is a conversion from a 4-ball Moss type ship, and that's akin, although not the same configuration as what's been done on the Hilly off northwest Africa, and there's also going to be done on the Gimme as well. Old 5-ball or 6-ball Moss ships, I think, which don't have any process, which would be normal FPSO type thing to do the separation and everything, but just does pure liquefaction. We then have to transport it. So there's our LNG carrier, and then we have to take it and regasify it. And this is rather than going to something like Canvey Island or another reception plant such as Milford Haven in Wales, in the UK, there are now floating regasification, storage and regasification plants, either converted from old LNG carriers, because all you need is some regas plant on there, or new builds. This is a new build, a large capacity new build with an LNG carrier. You can see the scale of it next to it. But also there's another element in the chain now, and that's bunker vessels. They never have existed because nobody ran bunkers for LNG. So now, as an addition to the regasification of the LNG after it's been stored, we now have the distribution in its liquid form for fuel on board a ship. So let's look at marine bunker fuel, and then the regulatory drivers of why there is a shift away from either heavy fuels or distillate fuels. And it's all to do with air emissions. I'm sure we're all familiar with this, which is driving that necessity to energy mix. And there are another number of options available, which I'll touch on in a later slide, for both the existing and new tonnage. And all of this has been driven by mainly international, but also regional requirements. The EU had their requirements to reduce CO2 emissions that came into force nearly 3 years ago now. Obviously, we've had the drive from IMO to reduce CO2 and also SOx emissions. CO2 is coming in in stages, and the SOX is now there and came into force at the 1st of January this year. Obviously, reduced emissions, you get reduced fuel cost and possibly carbon tax advantages, depending on the regime you're in. You could get reduction in through life machinery and maintenance cost, but also you get a reputational advantage for using a cleaner fuel. And for certain sectors of the shipping industry, that is absolutely paramount to the operation. So the drivers, just the two main ones that are from IMO, is to do air pollution. The first is the Energy Efficiency Index, which is driving down CO2 production per nautical mile, significantly. And you can see there's been a line of 2013-15 until we get to tier 3, phase 3, in 5 years' time, there would have been a 30% reduction. Obviously, we still need to go a lot further. There certainly is a good talk with Snamy West in a few weeks' time from LR on the use of fuels to try to get to the 2050 targets set by IMO and also governments. And then obviously we'll have the reducing of SOX sulfur, which is now a global limit of 0.5%, and obviously within the ECAs, which on the little map of the world up on the top there are the yellow areas, it's actually 0.1%. And you can also see the green areas, just, I'm sorry about the size, obviously there's proposed ECAs around Japan and in the Med, places like that. But there's also other drivers, not just regulatory drivers. There's the ports. The ports don't want ships coming in that are either perceived or do pollute the environment. So they want to introduce cleaner fuels, cold ironing, things like that to try to reduce emissions. There's a whole driver to reduce the footprint in all parts of the supply chain. We're all are feeling this, you know, as homeowners and drivers of cars and things like that. Why? Well, that's because of public pressure. And we are on a journey, and we're on a journey towards hopefully zero carbon emission fuels. Whether you believe in, whether you're on Mr. Trump or whoever, there is a drive to get that, and it's going to happen. And one of what I would call a transitory fuel is LNG, because it's still a hydrocarbon fuel, but it's a clean, relatively clean burning hydrocarbon fuel that's relatively low risk and well known within the marine environment. There are other ones, as you can see there. We have electricity, biofuels, hydrogen, methanol. There's ammonia. They all have pros and cons regarding particulate matter, SOx, NOx, carbon dioxide emissions. The only truly green ones, LNGs, there's the first column, which is the column here. That's LNG. It still produces CO2, ticks all the other boxes. This is distillate fuels. That's heavy fuels with a scrubber. That's heavy fuel oil with a SCR. But then you've got the pure green ones, which are potentially electricity, biofuels, depending on how you generate that electricity, of course, biofuels, hydrogen, methanol, and there's ammonia as well. One, as I touched on, one of the reasons why LNG is there, it's known. We have a lot of experience, but we don't actually have a bunkering infrastructure at all. We've got terminals. We have reception or production terminals, but we don't have a bunkering infrastructure that's there. And the temperature of the fuel, LNG, is actually quite important. You can't deal with something maybe that's down at sort of the high -150s. You want to be able to transfer it across at its low state. And the easy way to bring anything quickly to market is to convert, but you've also got to construct new vessels, and that's what we're going to talk about. Well, conversions, you're stuck with a parent hull. With new builds, you can maybe do something a little bit cleverer. Okay, current state of the sector. Well, it's in its infancy. It's a very, very young sector. The big problem is it's a young sector and we'll have nothing to copy off. Every good naval architect has his little black book, which maybe have a number of numbers in it, but it should have some numbers about ship designs that he can use, adapt, modify, distort. However, that isn't the case with these vessels. And very much the industry is feeling its way. It is making mistakes, but it is learning. And there's no fault in making a mistake as long as you learn from that mistake. And that's not just on a personal thing, that's on a corporate level or an international level. Because less than 10 years ago, nobody knew what the future of LNG fueled ships would look like, what would be, how you were going to bunker them, where the bunker tanks were going to be, what systems you were going to use, anything. Everybody was making it up to a certain degree, adapting existing technology, moving across, manipulating it. And therefore, the key document which describes a ship design, which is its specification, maybe wasn't as robust or mature as it maybe should be. They will be maturing now, and certainly nowhere as mature as a standard ship type. So if you go along and ask for a 15,000 ton, 15 knot cargo, general cargo ship, you can go to most shipyards and you'll get one, and you'll get it with some confidence. You will not get one of these with that sort of confidence. And even existing tonnage, which let's say small LNG ships, which there aren't actually that many around, below about 30,000 cubic meters. There's a few there, but we're talking about dozens compared to the hundreds of anything above 130,000 cubic meters. And there's only one or two spots in between those two figures at about 70. There actually aren't many, and they are trading ships. They are not bunker ships. They are different to a trading ship. A bunker ship is different to a trading ship, as a standard oil bunker barge is different to a standard coastal tanker, really. So, development of LNG fueling. Well, it's there. You can see there from this little slide. It covers a multitude of ship types, some very common, some not so common, some very specialized. And obviously there's a one that's missed out here, and that's the existing LNG carrier fleet. However, they don't need to be bunkered because they burn their cargo. So we know a little bit about how to do this. We can put this technology on board a ship, but we don't really need to bunker the ships that are actually going to carry the fuel, because they actually burn that boil off gas, which they don't if they don't need to re-liquefy it. Nowadays the hull forms are getting quite efficient in that the way back in the dim and distant past, an LNG carrier went as fast as its boil off rate produced fuel that burnt in the boiler that spun the turbine that spun the fan underwater and pushed the boat along. That's not the case now. The containment systems are very good, and the engines are so lean. Probably a lot of vessels do need reliquefaction on board, because they actually can't burn the boil off that's produced. So the key factors supporting this transition to LNG as a fuel. Obviously, you've got the IMO limits on sulfur, the EGAs, the emission control areas, which I showed a map of. But a lot of vessels, you can see there's a tanker being, and it's an LNG fueled tanker, being refueled by a little bunker barge, bunker ship. Well, it's not that little a ship. It's 100 meters long, that one. But they are very large. The fuel requirements are quite high. As I shall show soon, a lot of these bunker vessels are going to be like very, large coastal tankers. The fuel costs, as it says there, represent a high proportion of total operating costs. So if you can actually get a discount from burning gas rather than oil, you could actually get some significant savings on the operational, as well as assistance to the environment. Ships tend to follow routes that could be easily accessible LNG fueling. Now, I'll come to the numbers of ports where you can fuel, but a few years ago it was very little. And if you go back 100 years, you couldn't get liquid fuels, bar originally Rotterdam and Singapore. Where now we can bunker liquid fuels everywhere. So the infrastructure will come along with the ships. If you build it, they will come, as it was said in some film. And that infrastructure is coming because the demand is there now from owners. So the sector, there's a lot of people out there, there's a lot of things going on. One of the big influences towards this is that the government is supporting a lot of these new investment programs, the port authorities of wanting ships to deliver LNG fueled. Okay, so how many LNG fueled ships do I have? Well, as an example, as of this month, there were 129 cruise ships of various shapes, sizes and colours on the order book for delivery all the way through to 2028. 26 of them were LNG fueled. So that is a significant proportion of that fleet, and it's only going to go one way. In 2017, there were about 100 LNG ships in operation. At the start of this year, that had gone to 175, and there's currently about 200 on the order books. In addition to that, there is a significant number of ships that are fitted for but not with, to use a naval term, so could be easily shifted to LNG burning if required, either while still under construction or during a refit. Now, as I said previously, there wasn't many ports could do LNG bunkering. However, just in the last few years, that's grown significantly, and there's now 96 of the world's major ports got the ability to bunker LNG in one form or the other, and another 55 are in the process of adding those facilities. And because of recent orders, the newly produced CMA CGM, 22,000 tonner, 22,000 TEU container ships that are coming out of China now, have one large membrane fuel tank under the accommodation block, and because of that, there's had to be dedicated bunker ships built for them, and there's an example of one which is operated by MOL and came into service very recently, just a month or two ago. There's also pressure locally. The Norwegian Parliament a few years ago passed legislation that any ferry options would have to be emissions free by 2026. Now, there's lots of different types of emissions. That's not just air emissions, but that's also emissions of any grey or black water or particulate matter from there. Now, grey water, black water are probably, as with particulate matter, is probably easy and manageable, but NOx and SOx are a little bit more challenging. And that's why we're now going down this route of looking at alternative fuels. And a lot of smaller vessels with shorter routes are going to batteries or possibly hydrogen and bunkering very locally and after only shifts. But there's lots of different technologies out there, and I don't really want to go into them today. But just to show you, this is the first LNG powered cruise ship that came into service, the Ida Nova, which came into service a few years ago, and the most recent one, which is the Costa. I can never remember how to say this. Samalda. I don't know how to say it. And there she is bunkering off the coral methanes, bunkering on our first bunkers. So it is really pushing ahead. It's happening. It's real. Okay, bunker vessels. They come in all shapes and sizes, all the way from a couple of hundred cubic meters, as I say, all the way up to the new vessel produced by for MOL, which is nearly 20,000 cubic meters. In start of 2000 this year, there were 7 LNG bunker vessels in service, 3 smaller sort of river LNG bunker barges. However, there are over 20 now are on the order books, and probably another dozen or so will be delivered towards the end of this year, all the way above that 7. So from in a year, that number would have tripled or quadrupled, sorry, which is a significant growth, very fast growth. And as I say, it's not just bunker barges, which are easy to do, it's LNG bunker vessels. And these vessels are quite complex. They can be DP2 class. They've got to have fendering. They've got to be able to deal with the flash gas coming back. Some of them might have the ability or want a capability to have both oil and LNG to bunker, not just so they can bunker vessels which are running dual fuel, but they can bunker vessels that are still running on liquid fuels in maybe harbours that can't have more than one vessel. I don't know. And as I say, there's conversions of all different sizes and also new builds. There's some examples on the screen there. And just to highlight 2, this is the Karos, which operates in the Baltic and was commissioned a year or 2 ago. It's the largest one that uses Type C tanks. It's got 2 Type C tanks to give a total storage capacity of 7,500 cubic meters, and it's DP2. And this is the Gas Agility, which is the new MOL ship, which is to service the big container ships. It's in Northern Europe, I think Rotterdam at the moment, but I'm not exactly sure. And she's 18,600, but she uses membranes. So she's got the GTT Mark III Flex membranes. Okay, so let's talk about the scope and the development of these vessels. Right, let's put a ship owner's hat on. So you're a ship owner, you're going to enter a new sector. This sector is very immature and the operations are evolving. They've been adapted from operations on big vessels at terminals. The tonnage itself is extremely expensive, so you've got to have your utilization very high. A lot of ship owners now, unfortunately, compared to, let's say, 40 years ago, have limited technical departments. They have technical departments that can run and operate ships and modify ships, but not specify new ships and undertake a lot of R&D. Some do, I'm not saying all of them, but a lot do not. And there are numerous types of ships out there and operators, and this type could have a variety of requirements, some of them which may be conflicting to each other. Therefore, the outcome of this is that it's very difficult to produce a mature specification that's robust and will take you through the whole of the design cycle, potentially. Now, let's step on the other foot and look at the shipbuilder's angle. Well, what the shipbuilder wants to build is a low-risk, compliant technical response to the specification. However, if the specification isn't mature and robust, he's going to have difficulty complying with the technical requirements if the technical requirements can't be nailed down to a high level of maturity. Also, shipbuilding, it operates, as we all know, on low margins and there's fluctuating demand. At the moment, we're in a low, and it's a difficult time to be a shipbuilder. How does he get his commercial advantages? He does that through production and his processes. And he wants to produce the ship that he can produce because his facilities have been designed to produce, not particularly sometimes the ship that the ship owners require, even if, and sometimes, as I've said, they don't actually know what they want because they haven't been through that process yet. So the way a yard works, it works on, in essence, standard ship types, sizes, and families of design, which are built to match their production processes. And because of that, a lot of yards have a limited, potentially a very, very limited concept design capability. So the yards are trying to work off a spec that isn't mature, and they don't have sometimes the resources available to actually question that spec and work there. Also, a shipyard traditionally doesn't have a lot of understanding of how a ship operates. They build ships, they don't operate ships. And a lot of the staff within inside that organization sometimes do not understand how a ship is operated. And as I say, that results in designs that are designed and offered that suit the shipyard, maybe don't suit the ship owner for specialist ship types. So what's the outcome of this? Well, to quote another film reference, it's a perfect storm. Firstly, the exam question from the owner, well, it can't really be written. The owner doesn't know the operations, he can't robustly bound things, and he also has lack of guidance to guide that design development and go along that journey. And the poor old candidate sitting the exam, and that's the shipyard, he's learned a different syllabus maybe to what's being asked. He's got a lack of resources. Hasn't got time in that exam to fully assess the spec because he just hasn't got the time, and he's not really skilled at transposing operational requirements into maybe very novel designs. So a solution, well, like life, nothing's straightforward, but it can be achieved, and the industry is achieving it. It's taken time, but we are getting there. One thing that has to happen and is happening is that all stakeholders really have to work together and in a very collaborative manner and feel together, metaphorically holding hands. And this isn't just the ship owner, this is the ship receiving ship operator. So this is the operators of the ships that are going to be bunkered, and the ship owners, the ship designers, and the process designers, together with the shipbuilding aspects, and also industry organization regulators. You know, 10, 20 years ago, there was no regulations for doing this. There was no regulation for fuels, as LNG as a fuel. So the sector will mature, and LBVs will optimize, will settle on designs. But at the moment, we're still going on this journey together. So design for operations, final section. So any vessel has to be suitable for the purpose that it's been, well, procured. What do you need to do as a bunker ship? Well, you need to know what sort of size the ships are you going to bunker. What configuration are they going to have for either bunkering, for mooring, that sort of thing, where it's going to be undertaken. You're also going to have to bunker yourself. So the shore infrastructure has to be there. There could be very specific operational requirements. You're dealing with a high cryogenic fuel. And the whole outcome of this is the compatibility study between the vessel, the bunker vessel and the reception vessel, and the bunker vessel and the terminal. As it says there, you've got a couple of vessels there that are bunkering. You can see one's bunkering against a roll-on, roll-off ferry, the one on the left. The bottom right is bunkering a car carrier. They are different vessels, and tankers are different, and container ships are different. The configuration, the layout is all different. And ship owners are definitely coming to an understanding that an LNG bunker vessel is not just a bunker barge, and it's also not an LNG carrier, a traditional LNG carrier. It's got to do different things. So therefore, its arrangements, its principal dimensions, its fit, its kit, its operations, its layouts, all have to be engineered properly and understood to be able to produce an optimal and also a very safe and, at the end of the day, an economical design. Here just shows an illustration of a bunker operation. You can see this is it just happens to be the carross going up against roll-on, roll-off ferry, and you can see it there. It's lifting the flexible hoses from the manifolds on the tanker towards the gun port doors in the side of the ships. Well, gun port doors, were you going to have them? Well, 10 years ago, a lot of the thoughts were you'd have to have manifolds on the main deck. Well, now we'll put gun port doors in. We've got round the regulations to do that. We've assured ourselves it's safe. We're operating them more like you would a standard liquid fuel. You can see the fenders in between the ships there, because obviously in the world of LNG carriers, thou shalt not touch. So it just shows some of the bunker operations. So design characteristics, as I've said, it's a very little known and it's a very advanced ship type. It's got some very unique operational requirements and technical challenges. And we don't have any standard designs, but it has some very specific design drivers. We're having to adapt common technologies to marinize some that weren't marinized before, and introduce some new ones, both within the hull systems, but also the cargo systems compared to a standard LNG carrier. And really, this requires, you know, as a whole supply chain, all the way from the financiers through probably to the insurers and everybody else in between, to have some new thinking, to collaborate. And, you know, as I said, that's all the way from the reception ships back to the shipbuilders. The design is a lot more complex than a standard LNG carrier of a similar size, and the operations must have a solution that's robust and that's safe to operate, and that's absolutely imperative. So what specifics are not the same? Well, the parallel middle body, for starters. A normal LNG carrier moors to an LNG mooring system, which may be a key, may have dolphins, may have that, but you've now got to deploy fenders. So the traditional parallel middle body might not be sufficient. The principal particulars, one of the key drivers in any ship design, okay, if it's conversion, you cannot have this, but the principal particulars will affect, rather than anything else, the performance of that ship design, and this should be tied in to the operational requirements. And quite possibly, and it is the case, that these wouldn't follow standard dimensional ratios as for either bunker barges or small LNG carriers. Subdivision, your ballasting requirements might be vastly different. Stability can be an issue with these. They've got a lot of stuff on the top sides. The marine operations could be different, or are different. The hull form, well, it's got to be able to maneuver. It's maybe got to have minimal wash. You've got to allow now for a larger, flatter side, maybe. It's not going to transit as much, but it's maybe going to have to operate in very low underkeel clearances and have that sort of thing. So the whole hull form changes slightly. Manifolds, obviously the location of these manifolds, the location of the alignment has to match up with what you're going to supply. And at the moment, it's quite a fluid environment. You might have to have multiple manifolds, and a lot of the bunker vessels do have that, because now you have not just bow loading, but stern loadings. You have bow loadings. You have side-by-side loading. You have to have access to the LBV from the LBV, sorry, to the receiving ship. And that's a very important to undertake the cargo offtake. And remember, the cargo offtake, this is a proper thermodynamic offtake. You don't just put the pumps on and just wait until the tanks are full. You have to actually manage the process properly. And therefore the safety zones, you know, we are dealing with cryogenic fluids, and that will become a gas cloud if there's any spillage. Obviously the safety zones around there are absolutely paramount and different to other ship types. So I've come to the end. Hopefully you've enjoyed it. Some things to take away. LNG, it is arguably the marine fuel of choice. It is transitory at the moment. It'll probably see me out in my career, I think, but certainly in the next 30 to 40 years, it'll be maybe the fuel of choice. So in the next 20 years, anyway. We do need investment, not just in the vessels, but also the port infrastructure. That is not there. These little vessels can't go against something that's meant for a Q-Max tanker to go and get the LNG they need to do. As I've described, the industry's feeling its way, but we are learning. We're learning by mistakes. That's not a bad thing, you know. There's nothing wrong with having cuts and bruises. That's just showing that you've learned. If you keep, however, that's a bad thing. But we need to collaborate together as a cohesive team of sometimes disparate technologies trying to come together. And just one last thing, and that's on the compatibility study. It's absolutely key. You've got things that need to talk to each other, and they need to talk to each other in a safe and robust manner. So that's the end of me. You now know that LBVs, it isn't just port, it isn't late bottle vintage, it's also LNG bunker vessels. So I'd be happy to take any of your questions, and thank you very much.